Hi, can we quickly look at this problem together? Find x if a raised to the power of x plus a raised to the power of minus x equals to 2, where a is greater than 0 and a is not equals to 1. And you have a raised to the power of x plus a raised to the power of minus x equals to 2. Now the first thing to do to this equation is to express this one as a reciprocal of a raised to the power of x. So this equation turns to a raised to the power of x plus 1 over a raised to the power of x equals to 2. Alright, you get that? So now the next thing is to make an assumption that is saying let k be equals to a raised to the power of x, because what we have here now is in terms of a raised to the power of x. So this equation turns to k plus 1 over k equals to 2. Get that? So now the next thing is to multiply through by the LCM of the denominator, that is k. Multiply this by k. When you multiply this by k, you have k squared plus, when you multiply this by k will cancel k. So you have 1 plus 1 equals to, multiply this by k, you have what? 2k. Right? So now this turns to k raised to the power of 2 minus 2k plus 1 equals to 0. Now this is a quadratic equation. So we solve this by factorizing the left hand side. Right? So now let's look at this expression here. The left hand side, we have the sum as a minus 2 and the product to be what? To be 1. The coefficient of this times this. That's 1 times 1. That's the product. The sum is the coefficient of k. So now you look for two numbers such that when you add together, you have minus 2. And when you multiply the two numbers together, you have plus 1. The two numbers are minus 1 and minus 1. Why are we doing this? We want to divide this middle term into two terms, right? So now that means minus 2k we turn to minus k minus k. That gives us minus 2k. So this equation turns to k raised to the power of 2 minus k plus 1 equals to 0. You get that? So now let's look at the first pair. So you look for the common factor. That is the value that will go in these two terms. Right? That's k. So now when you divide this by k, you have k. When you divide this by k, you have minus 1. Now the common term here is minus 1. So you factor out minus 1. So you are left with k minus 1. Right? You know when you divide this by minus 1, you have minus 1 equals to what? 0. Right? So now the common factor here is k minus 1. So this equation turns to k minus 1 equals to 0. Right? We have k minus 1 equals to 0, or k minus 1 equals to 0. Right? So k equals to 1 or k equals to 1. So you can simply write k equals to 1 twice. Okay? So now k is a raised to the power of x. So this turns to a raised to the power of x equals to 1 twice. Alright? This is an indicial equation. So you turn this to logarithmic equation. So this turns to x equals to log of 1 base a. Right? So now x will be log of 1 over log of a. Now this is change of base, right? So therefore x equals to, now log of 1 is what? 0 divided by log of a. Right? So therefore x will be equals to what? That will be 0. So x is 0.